Wet concrete exerts pressure, not a little pressure, a lot. A 4-foot tall wall form full of wet concrete exerts approximately 600 pounds per square foot of lateral pressure at the bottom of the form. The weight of 4 feet of liquid stone pushing outward against the plywood and the stakes that are supposed to hold it in place. On a 40-foot wall, the total outward force at the base is approximately 24,000 pounds, 12 tons of lateral pressure pushing against the forms from the inside. If the forms hold, you get a wall. If the forms fail, you get a catastrophe. 12 cubic yards of wet concrete flowing across the ground like gray lava, filling the trench, burying the rebar, surrounding the anchor bolts, and setting into a hardened mass that can only be removed with a jackhammer, a crane, and approximately $8,000 in labor. A blowout doesn't just ruin the pour, it ruins the day, the week, and the budget. On a Friday afternoon in October of 2001, a concrete contractor named Rick Dysart poured the foundation walls for a new machine shed on the Vickers farm outside of Gallatin, Missouri. The shed was 40 feet by 60 feet, a standard pole building with a concrete stem wall foundation, 4 feet tall, 8 inches thick, running the full perimeter. 200 linear feet of wall. The forms were commercial aluminum panel forms, rented from a form supply company in Kansas City, supported by steel stakes driven every 24 inches and braced with diagonal kickers every 4 feet. The pour went in at 2 p.m. 3 ready-mix trucks, 12 yards total, delivered in sequence over 2 hours. Then the concrete was a standard 3,000 pounds per square inch mix with a 5-inch slump. Wet enough to flow and consolidate around the rebar, but stiff enough to develop initial set within 4 to 6 hours. Rick's crew, 2 men, vibrated the concrete into the forms, struck off the top, and finished by 4:30 p.m. The concrete would set overnight. The forms would be stripped Monday morning. The wall would be ready for the pole building framing by Tuesday. That was the plan. The plan survived until midnight. At 12:15 a.m., the south wall form blew out. The failure started at the corner, the junction where the south wall met the west wall. The steel stake at the corner had been driven into fill dirt instead of native soil. Fill that had been placed during the site grading 2 weeks earlier, and that hadn't been compacted. And the stake held during the pour because the concrete was flowing slowly and the pressure built gradually. But as the concrete filled the form and the full hydrostatic pressure developed, the stake in the uncompacted fill began to lean, tilting outward 1 degree, then 2, the fill yielding under the lateral load. At approximately 1 inch of stake deflection, the form panel at the corner separated from the adjacent panel. A crack opened, 1 inch wide, 4 feet tall. Wet concrete. Still plastic, not yet set. 6 hours into a 12-hour initial set. Began flowing through the crack. The flow exerted additional force on the adjacent panels. The next stake leaned. The next panel separated. The blowout cascaded, panel by panel, stake by stake, along 12 feet of the south wall form, in the wet concrete flowing through the widening gap and spreading across the ground. Rex Vickers, the farmer, 64 years old, the property owner who was paying for the foundation, was in bed. He heard the sound, not a crash, a slow, heavy, wet sound. Like mud sliding down a bank, the sound of 12 cubic yards of wet concrete, finding a way out of a form that couldn't hold it. Rex pulled on his boots and walked to the site with a flashlight. What he found was the south wall form collapsed for 12 feet, 4 panels down, 6 stakes leaning, wet concrete flowing through the gap and pooling on the ground beside the trench. The flow had slowed. The concrete was thickening as it set, and the volume that had escaped was approximately 1.5 cubic yards. The remaining 10.5 yards were still in the forms, in still plastic, still exerting 600 pounds per square foot at the base of every panel that was still standing. Rex called Rick Dysart. "Rick, your south wall form blew out. The corner stake was in fill. 4 panels are down. Concrete is flowing out." "How bad?" 12 feet of form is gone, about 1.5 yards on the ground. The rest is still in the forms, but it's pushing hard. If another stake goes, the whole south wall is coming out. I can't get there until morning. My crew is in St. Joe. I'm in Kansas City. It's 3 hours. By morning, the concrete will be set. If the rest of the forms blow before the concrete sets, you'll have 12 yards of hardened concrete on the ground and no wall. I need to stabilize the forms now. You need to shore the panels that are still standing and rebuild the section that blew. You'd need form lumber, stakes, and bracing. I have barn lumber. I have stakes. I have a farmall and a sledgehammer. I'll have the forms rebuilt before the concrete sets. Stay with me, because what Rex Vickers built between midnight and 5 a.m. in the dark with a flashlight, using lumber from his 1917 barn, is why this story is about understanding pressure instead of following a form manual. Let me tell you about Rex Vickers, because the farmer who rebuilt the forms at midnight was not a man who poured concrete for a living. He was a man who understood what concrete does when it's wet, what forms need to do to hold it, and why the contractor's forms had failed where his barn lumber would not. Rex had been farming 320 acres in Davis County since 1970. He'd poured concrete his entire life: barn floors, feed bunks, water troughs, and fence post footings, equipment pads, not foundations. He'd hired Rick for the foundation because the stem wall required commercial forms and a ready mix pour that was beyond Rex's usual scope. But the fundamentals of formwork, the physics of lateral pressure, the mechanics of bracing, and the relationship between stake depth, soil type, and holding capacity were as familiar to Rex as the workings of his tractor. Rex understood why the forms blew. The contractor had driven the corner stake into fill dirt. Fill dirt, uncompacted, recently placed, loose, has approximately 1/3 the lateral bearing capacity of native soil. A stake in native soil resists the concrete's outward push because the undisturbed soil is dense, stable, and has been compacted by decades of its own weight. A stake in uncompacted fill resists nothing. The fill yields, the stake leans, the form opens, the concrete flows. The fix was not complicated. The fix was deeper stakes in native soil with diagonal bracing that transferred the concrete's lateral force into the ground at an angle instead of relying solely on the stake's vertical embedment. The contractor's bracing had been diagonal kickers every 4 feet, adequate for stakes in native soil, inadequate for stakes in fill. Rex's fix would be diagonal bracing every 2 feet, with stakes driven to refusal in native soil, not the 2-foot depth the contractor had used, but 4 feet, driven until the sledgehammer couldn't move them another inch. If you're enjoying this story, consider subscribing to The Average Farmer. We share stories like this every week. Now let me tell you about the barn lumber. because the material Rex used to rebuild the forms was not construction-grade dimensional lumber from the lumberyard. It was rough-sawn white oak from his 1917 barn, boards and timbers that had been part of the barn's hayloft floor, removed during a renovation in 1994 and stacked in the machine shed ever since. The barn lumber was rough, unplaned, ungraded, varying in width from 6 inches to 12 inches, varying in thickness from 1 inch to 2 inches. It was white oak, a hardwood with a bending strength of approximately 14,000 pounds per square inch, nearly twice the strength of the Douglas fir or southern pine that commercial forms are made from. The oak was 7 years into its air-drying process, hard as iron, the moisture content below 12%, the wood stable and strong in a way that kiln-dried construction lumber never achieves. The lumber was ugly. It had nail holes. It had saw marks. It had bark edges on some boards. It was the kind of lumber that a contractor would look at and say, "You can't build forms out of that." And the contractor would be wrong, because forms don't need to be pretty. Forms need to be strong. And rough-sawn white oak that's been curing for 7 years is the strongest lumber on a Missouri farm. Rex went to work at 12:45 a.m. He backed the Farmall 560 to the machine shed, loaded the hay wagon with barn lumber, 18 boards of varying width and thickness, plus 6 4x4 oak posts for stakes, plus a stack of 1x4 oak strips for diagonal bracing. He drove the wagon to the pour site and parked the Farmall with the headlights illuminating the blown section and started building. Everything was about to be rebuilt in 4 hours. But Rex had one thing the contractor's aluminum forms didn't: lumber that was stronger than the concrete, pushing against it. Step 1. Stabilize the standing panels. Rex started with the forms that were still holding. The panels on either side of the 12-foot blowout that were bulging under the concrete's pressure, but hadn't yet separated. He drove oak 4x4 stakes, 4 feet long, into the native soil beside each existing steel stake, using the sledgehammer to pound the oak past the fill dirt and into the hard clay beneath. The oak stakes went in beside the steel stakes, doubling the holding capacity at each point. He nailed diagonal braces, 1x4 oak strips, from the top of each stake to a second stake, driven at an angle 2 feet behind the form. The braces triangulated the holding system. The form pushed outward. The brace transferred the force downward and backward into the ground stake. And the ground stake held because it was in native soil at 4 feet of depth. The standing panels stopped bulging. The doubled stakes and the additional bracing locked the forms in place. The concrete pushed, the forms held. The first crisis, a cascade blowout of the entire south wall, was averted. Step 2. Clean the blowout zone. Rex shoveled the escaped concrete, 1.5 yards of wet, thickening mix, away from the trench. The concrete was still plastic enough to shovel, but stiffening by the minute. As he worked fast, 15 minutes to clear the 12-foot section, scraping the concrete off the rebar and the anchor bolts that were set in the trench floor. The rebar was still in position. The anchor bolts were still plumb. The escaped concrete hadn't displaced the steel. It had flowed over it and around it without moving it. The trench was salvageable. Step 3. Rebuild the forms. This was the main event, constructing new forms from barn lumber to replace the 4 collapsed aluminum panels strong enough to hold the concrete that was still in the form on either side of the blowout, and that would refill the repaired section when Rex poured the patch. Rex built the replacement forms the way his father had built every form on the farm, from boards, stakes, and bracing, without panel systems, without hardware, but without anything purchased for the purpose. The form face was 2 layers of 1-inch oak boards, the first layer nailed vertically to the stakes, the second layer nailed horizontally across the first, creating a double-thick form wall that was stronger than the single layer of plywood on the aluminum panels. The double layer also prevented leakage. Wet concrete seeps through gaps in single-layer forms, creating fins on the wall surface that have to be chipped off. The double layer's crossed grain sealed the gaps. The stakes were 4x4 oak posts, driven 4 feet into native soil on 18-inch centers, instead of the contractor's 24-inch spacing. The tighter spacing distributed the concrete's pressure across more stakes, and reducing the load per stake from approximately 1,200 pounds to approximately 800 pounds, well within the holding capacity of a 4x4 oak post embedded 4 feet in Missouri clay. The bracing was the critical improvement. Rex braced every stake, not every 4th stake like the contractor, but every single one. Each stake had a diagonal brace running from the form top to a ground stake 2 feet behind. The braces were 1x4 oak strips nailed at both ends, creating a triangle that resisted the concrete's outward push. At every support point along the form, the system was overbraced by commercial standards. The contractor would have called it overkill. Rex called it holding. That moment, the last brace nailed, the rebuilt form standing solid in the farmall's headlights, changed everything about the pour. And the concrete that would fill the repaired section would never move a board. By 3:30 a.m., the rebuilt forms were complete. 12 feet of double-layer white oak formwork staked every 18 inches, braced every 18 inches, driven to refusal in native soil. The rebuilt section was aligned with the standing aluminum panels on either side. Rex had used a string line to set the form face at the same plane as the adjacent panels, ensuring that the finished wall would be straight through the repaired section. Step 4. Pour the patch. Rex had a problem. He needed approximately 1.5 cubic yards of concrete to fill the rebuilt section, the volume that had escaped during the blowout. The ready-mix plant in Gallatin didn't open until 7 a.m. He couldn't wait. The concrete in the standing forms was setting, and the longer he waited, the harder the junction between the old pour and the new pour would be to integrate. A cold joint, a visible line where old concrete meets new, would be a structural weakness and a cosmetic flaw. Rex mixed the concrete by hand. He had bags of Portland cement in the barn, left over from fence post footings. He had gravel and sand from the creek bed, the same aggregate source that the ready-mix plant used. He mixed in a wheelbarrow, 1 bag of cement, 3 shovels of sand, 4 shovels of gravel, water from the hose. Each batch made approximately 2 cubic feet of concrete. He needed approximately 40 cubic feet, 20 batches, 20 trips from the mixing station to the forms with the wheelbarrow, 20 shovelfuls of cement, 60 shovelfuls of sand, 80 shovelfuls of gravel, 20 hose fills. Rex mixed, wheeled, poured, and vibrated, using a piece of rebar as a vibrator, jabbing it up and down in the wet concrete to consolidate it around the existing rebar and the anchor bolts. If you're enjoying this story, consider subscribing to the average farmer. We share stories like this every week. By 5:15 a.m., 4.5 hours after the blowout, the repaired section was full. The concrete was level with the top of the forms. The surface was struck off and floated smooth. The repaired section was indistinguishable from the sections that hadn't blown. The same height, the same thickness, the same alignment, the same finish. Rex turned off the Farmall's headlights. The sky was lightening in the east. October dawn at approximately 5:45 in northwest Missouri. He sat on the Farmall's fender. He drank coffee from a thermos Arlene had brought him at 3 a.m. and watched the forms in the growing light. The oak lumber, rough, nail-holed, bark-edged, held the concrete with the calm indifference of wood that's been bearing loads since 1917. The bracing didn't creak. The stakes didn't lean. The forms didn't move. The contractor's aluminum panels, engineered, manufactured, rented at $2.40 per linear foot per day, had blown out at midnight because a stake was in the wrong dirt. The farmer's barn lumber, rough-sawn, air-dried, salvaged from a hayloft renovation, held the same concrete from midnight to Monday because the stakes were in the right dirt and the bracing was at every point. That moment, sitting on the Farmall at dawn, the forms holding, the concrete setting, the work done, changed everything about how Rex thought about hired work. And Rick Dysart, when he arrived at 8 a.m. to survey the damage, would never forget the sight of the repair. Let me tell you about Monday morning, because Rick Dysart arrived at the Vickers farm expecting a disaster and found a completed foundation. Rick drove up at 8 a.m. He'd spent the 3-hour drive from Kansas City preparing himself for the worst. 12 yards of concrete on the ground, the rebar displaced, the anchor bolts buried, the entire pour destroyed. He expected to see a failure that would cost $8,000 to remediate, jackhammer the escaped concrete, reset the rebar, reset the anchor bolts, rebuild the forms, and re-pour. What he found was a foundation wall, 200 linear feet, 4 feet tall, 8 inches thick. And the south wall form, at the 12 feet that had blown, was rebuilt in rough-sawn white oak, the boards dark and weathered against the bright aluminum of the commercial panels on either side. The concrete inside was set, solid, smooth, the surface properly finished. The forms were holding without a deflection. Rick walked the perimeter. He checked the wall alignment with a string line, straight, within a 1/4 inch over the entire 200 feet, including the repaired section. He checked the wall height, consistent, within 1/8 of an inch. He checked the anchor bolt positions, plumb, properly spaced, properly embedded. The repair was invisible from the inside of the forms. The concrete surface was continuous, with no cold joint visible, where the original pour met the patch. Rex, you rebuilt the forms and re-poured. I rebuilt the forms with barn lumber and poured 20 batches of hand-mixed concrete. Took 4.5 hours. Hand-mixed concrete. Portland, sand, and gravel from the creek. Same aggregate the plant uses. 3:1:4 ratio. 5-inch slump. I vibrated every batch with a piece of rebar. The forms are barn lumber. Rough-sawn white oak from my 1917 hayloft. 2 layers crossed, stakes every 18 inches, driven to refusal. Diagonal braces at every stake. The forms are overbraced because I'd rather carry extra lumber than pour concrete twice. You saved the pour. I saved $8,000 in remediation. Your forms blew because the corner stake was in fill. My forms held because my stakes are in native clay at 4 feet. The difference isn't the forms, aluminum or oak. How it doesn't matter. The difference is where the stake stops. Your stake stopped in loose fill. Mine stopped when the sledgehammer couldn't drive it any further. Rick stripped the forms on Monday afternoon, 3 days after the pour. The concrete hard, the cure progressing normally. The aluminum panels came off cleanly. Smooth wall surface, consistent thickness. The barn lumber section came off differently. The rough oak left texture on the concrete surface. The crossed grain pattern visible as a subtle impression in the wall face. The texture was visible but not objectionable. The concrete was solid, straight, and structurally sound. The barn lumber section has texture, Rick said. The barn lumber section held. The aluminum section blew. The building inspector will check the wall for strength, straightness, and anchor bolt placement. He won't check it for texture. The texture doesn't hold up the building. The concrete does. And the concrete is there because the forms held. Let me tell you about the building inspection, because the Daviess County building inspector who checked the foundation wall the following week was the final judge of whether barn lumber forms could produce a code-compliant foundation. The inspector, a man named Gene Lackey, 20 years with the county, arrived on Thursday. He checked the wall dimensions, the rebar placement, the anchor bolt positions, and embedment depth, the wall alignment, and the concrete strength verified by test cylinders. The contractor's test cylinder broke at 3,200 pounds per square inch, above the specified 3,000 pounds per square inch minimum. The wall was straight, the anchors were plumb. The rebar was properly placed. Rex's hand-mixed patch section tested at 2,950 pounds per square inch from a separate cylinder Rex had cast during his pre-dawn mixing, within the acceptable tolerance of -100 pounds per square inch that the building code allows for field-mixed concrete. Gene approved the foundation. No deficiencies, no notes about the form material. I've inspected foundations for 20 years, Gene told Rex. I've never seen barn lumber used as formwork. But the code doesn't specify form material. The code specifies concrete strength, wall dimensions, rebar placement, and anchor bolt positions. Your wall meets every specification. The forms are a means to an end. Your means was unusual. Your end is code compliant. If you're enjoying this story, consider subscribing to The Average Farmer. We share stories like this every week. Let me tell you about the JD dealer. Because Wade Fulbright enters this story from the equipment angle. Specifically, the question of what equipment a farmer needs to solve a problem at midnight. Wade ran the John Deere dealership in Gallatin. He didn't sell concrete forms or mixing equipment. That wasn't JD territory. But he sold the skid steers, backhoes, and material handling equipment that concrete contractors used on job sites, and he heard the Vickers story at the co-op the following week. Rex Vickers rebuilt a blown concrete form at midnight with barn lumber. Hand-mixed 1.5 yards of concrete in a wheelbarrow. The contractor's $12,000 worth of rented aluminum forms blew out, and the farmer's oak boards from 1917 held the pour. Wade drove to the farm. He found Rex in the machine shed, unstacking the barn lumber from the wagon and restacking it for the next time it was needed. Rex, Wade, you rebuilt concrete forms out of barn lumber. White oak from my hayloft. The contractor's aluminum panels blew because the stakes were in fill. My oak boards held because the stakes were in clay, and I braced every 18 inches instead of every 4 feet. I sell equipment that moves material on job sites. The contractor rented aluminum forms that failed. You used lumber you already had that worked. Is there a lesson in this? The lesson is that materials don't fail, systems fail. The aluminum panels are fine. They're strong, they're straight, they're designed for the job. They failed because the staking system wasn't adequate for the soil condition. And my barn lumber isn't designed for formwork. It's hayloft flooring from 1917. But my staking system was adequate because I understood the soil and I braced for the pressure. The forms don't hold concrete. The bracing holds forms. The soil holds bracing. If the soil is wrong, the whole system fails, no matter how expensive the forms are. You're saying soil is more important than forms. I'm saying the weakest link determines the system's capacity. The contractor's weakest link was a stake in fill. My weakest link was batai. Well, nothing failed. When every component is adequately matched to the load, there is no weakest link. The $12,000 aluminum forms failed because of a $2 steel stake in the wrong dirt. My $0 barn lumber held because every $0 oak stake was in the right dirt. Let me tell you about the aftermath and how this ends. Now, Rick Dysart changed his staking practice after the Vickers job. He now probes every stake location before driving, pushing a rebar rod into the ground to check for fill, soft spots, or disturbed soil. If the rod goes in easily, he moves the stake or drives deeper. The probe takes 10 seconds per stake. The stakes that failed at the Vickers corner would have been identified in 10 seconds and relocated. The $8,000 blowout that Rex prevented would never have happened. Rex taught me that the foundation isn't the concrete, Rick told a concrete contractors meeting in 2003. The foundation is the soil under the stakes. The concrete is the product. The forms are the mold. The stakes are the structure, and the structure stands on the soil. If you don't know the soil, you don't know whether your forms will hold. Bay Rex knew the soil because he'd been farming it for 31 years. I didn't know the soil because I'd been on the site for 1 day. The farmer knew more about the ground than the contractor. Rex Vickers farmed until 2014, when he retired at 77. His son, Clay, runs the 320 acres. The machine shed stands on the foundation that Rex saved at midnight. 40 by 60, pole building. The stem wall straight and solid beneath the steel poles. The textured section on the south wall. The 12 feet where the barn lumber left its impression on the concrete is visible if you know where to look. Clay shows it to visitors the way a man shows a scar, with pride, not apology. The barn lumber is in the machine shed, stacked and ready. Rex used it for forms twice more, a feed bunk in 2004 and a water trough in 2006. Both times, the rough sawn oak held the concrete without complaint. The lumber was, by Rex's estimate, the most versatile material on the farm. Hayloft flooring for 77 years, form lumber for 5 years, and prepared to be whatever the next job required. The Farmall 560 is in the barn. Its headlights had been the only light source during the rebuild. 2 sealed beams illuminating the formwork while Rex nailed oak and drove stakes in the Missouri dark. Clay uses the Farmall for chores. and for the memory. The memory of his father working by headlight, saving a pour that a contractor couldn't save from Kansas City, using lumber from a barn that his grandfather had built before the First World War. Gene Lackey, the building inspector, retired in 2012. He tells the Vickers story at every building inspection seminar he attends. The code doesn't specify form material. The code specifies the wall. Rex's wall met code. The barn lumber was ugly. The wall was perfect. The code cares about the wall. I care about the wall. The lumber's just how you get there. If this story stayed with you, subscribe to The Average Farmer for more. We'll see you in the next one. The contractor built the forms to hold concrete. The farmer built the forms to hold pressure. The concrete didn't care what the lumber looked like. It cared that the forms didn't move. $12,000 in rented aluminum forms, one stake in the wrong dirt, a blowout at midnight. $0 in barn lumber, every stake in the right dirt. A pour saved by dawn. Because materials don't fail, systems fail. And the farmer who understands the system, the pressure, the bracing, the soil, the stakes, can rebuild at midnight with whatever lumber is in the barn and have the forms holding before the contractor's phone stops ringing.